A vehicle traveling at highway speeds experiences a catastrophic tire blowout, but instead of swerving into a ditch, the driver maintains perfect control. That stability is achieved through specialized safety systems built directly into the tires, allowing them to function even when severely compromised. When a manufacturer develops a product like this, there is a temptation to view bringing it to market as a basic logistics problem. Logistics focuses heavily on physical execution, packaging a unit, putting it on a truck, and moving it from point A to point B. Supply chain management is a much wider discipline. It requires integrating demand planning, capital flow, software infrastructure, and external risk mitigation into an interrelated web. If a company relies entirely on a linear logistics mindset, they remain completely blind to massive, uncontrollable disruptions. This photograph shows severe winter weather conditions in the United States, effectively freezing transit routes and halting regional supply. And this image captures an organized labor stoppage at a major port, which can throttle the movement of international shipping containers for weeks. Overcoming highly variable threats on a global scale requires engineering a strategic supply chain architecture rather than simply expanding a fleet of delivery trucks. Consider the challenge of our safety tire manufacturer attempting to enter the massive U.S. market for the first time. Their product appeals to three distinct buyer profiles: government emergency forces, private sector vehicle manufacturers, and the general public. A manufacturer cannot effectively serve all three of these customer types through a single delivery path. This map of the United States illustrates the geographic and demographic spread of those specific markets, branching out to police departments, industrial factories, and individual homes. Reaching them requires a framework known as distribution channel design. To survive market entry, the company must engineer three entirely distinct channel architectures, customizing each one to the exact purchasing behaviors of the target segment. This image highlights an emergency medical vehicle, representing the government sector, where these safety tires are highly critical. This market is heavily fragmented, widely dispersed across thousands of local precincts, and involves complex transactions for multiple fleet items. Government entities managing life and death services will not accept the unverified claims of a new, foreign manufacturer. This organizational flowchart maps the solution, inserting a trusted third-party intermediary directly between the manufacturer and government end users. These regional distributors use pre-existing relationships and rigorous vetting processes to prove the product's value to precinct commanders. We label this structural setup an indirect distribution channel. In high-stakes, fragmented public markets, intermediaries serve as essential vehicles for establishing trust and consolidating localized sales. The private sector segment, specifically original equipment manufacturers and large trucking fleets, presents a completely different environment. The customer base is heavily concentrated, consisting of very few buyers who place massive order quantities. Selling to these manufacturers requires extensive upper management negotiations to integrate the safety tires directly into the original vehicle assembly line. Updating our flowchart, we draw a single uninterrupted line straight from the manufacturer to the massive OEM node. The manufacturer relies entirely on its internal sales force to execute these complex agreements. This one-to-one relationship is known as a direct channel, or zero-level channel. For concentrated, high-volume industrial buyers, removing intermediaries maximizes profit margins and ensures precise technical alignment between companies. The final segment, the general public, is the most chaotic of the three. Consumers are extremely geographically dispersed, and they typically purchase in tiny, erratic volumes of just 1 to 4 tires at a time. It is economically impossible for a primary manufacturer to process, ship, and provide customer service for millions of individual localized orders. Returning to the flowchart, we map a multi-tiered cascade. The manufacturer supplies a wholesaler who distributes to retail sheds, cascading to individual consumers. Wholesalers absorb the inventory burden. Local sheds generate awareness and install the product. This is a two-level indirect channel. Consumer markets require deep, multi-layered networks because local intermediaries provide the only cost-effective way to absorb the logistical friction of small batch fulfillment. The manufacturer must operate all three of these vastly different channel structures simultaneously. To manage that complexity, they deploy Enterprise Resource Planning, or ERP, software. Supply chain visibility modules analyze data across the nodes to spot risks and proactively manage demand fluctuations before they crash the network. That digital tracking also enforces environmental accountability, an area known as supply chain sustainability. The sprawling two-level consumer channel naturally generates a massive carbon footprint due to constant localized vehicle transit. This animation overlays digital data pulses across the network, showing how modern firms use software to track that impact, purchasing carbon offsets to fund eco-initiatives that neutralize their emissions. In modern markets, a well-designed distribution channel relies entirely on software visibility and strict environmental accountability to remain viable. This tripartite flowchart shows the manufacturer's entire U.S. operational model. Notice the contrast between the stark efficiency of the zero-level industrial channel and the chaotic sprawl of the consumer network. Traffic flows in both directions. Capital, data, and risk flow backward as products flow forward. Examining this complete structure renders the traditional metaphor of a linear supply chain obsolete. Modern supply chain management requires directing a highly dynamic, multi-directional, interrelated web. Attempting to treat this complex web as a simple delivery chain guarantees catastrophic failure during a market entry. This brings us back to the distinction between logistics and supply chain management. This captures the extreme scale and speed of modern automated warehousing. But physical fulfillment is a commoditized action any firm with capital can buy. Market dominance and profitability do not stem from having faster trucks or bigger storage facilities. Dominance is achieved by matching specific structural distribution topologies to specific customer behaviors. Intelligent distribution channel design creates a sustainable competitive advantage. The company that engineers the smartest, most adaptable interrelated web is the one that ultimately owns the market.